our discussion is about the problem of rank of matrix. So, in our previous lecture, we have discussed the concept of the rank of matrix, what what is actually the rank of any matrix and how to determine it with the help of submatrix and minors. So we have already learned that what are the subminors, what are the square submatrix. Now today we'll discuss some problems about the rank of matrix. So at first I'm taking one example. Suppose you have any matrix A that is given by 1 2 3 1 4 2 and 2 6 5. Now you have to determine the rank of the matrix. So how to do this? So in this example, we can do this because you should know that the rank of any square matrix, actually you can determine the square matrix, rank of any square matrix by the help of the minor concept and submatrix concept. But many times there are some matrices which are not a square matrix. Okay. Here the matrix is obviously a square matrix because the matrix is 3 cross 3 order. So you can determine the minor of the matrix with the help of you can determine the minor of the matrix and also the rank of the matrix with the help of submatrix concept, that is the order of minors which have non-zero determinant. Okay, so we can do this also. And there is another method, that is the rank of any matrix. You can determine the rank of any matrix by the help of elementary row and column operations. Okay, or you can say that if there are two rows, that is non-zero rows in any matrix, this will be also considered as the rank of two matrix. Okay, so we know that two row matrix having the rank 1 2, we have learned that three row submatrix or three row submatrix, you can determine three row submatrix. So it has the rank of 3. Okay, so there are many types of concepts. Now we are determining the rank of the matrix. Okay, so how to determine this? By the help of row and column operations. So suppose this is the matrix. Now this is row 1, this is row 2, and this is row 3. Now you can determine the rank by the help of row and column operations. So at first, to do this, you have to make this and this element. Always take this and this element and make them 0 with the help of this element. Okay, so here we have this 3 cross 3 matrix. Look at this. Here we have 3 cross 3 matrix. So at first you have to make these two elements 0 by the help of this element. Then you have to make 0 this element with the help of this element. So we will follow this procedure to determine the rank of the matrix. So at first you have to make this and this element with 0 with the help of this element. So do this. If we subtract this R2, that is modify this row R2 like this, R2 minus R1, then it will be 0. And then we have to do, that is R3, we have to modify this R3, that is equals to R3 minus 2 into R1. So do this. We have the matrix A equals to 1 2 3, then 1 4 2, then 2 6 5. This is our original matrix, and if we do these types of operations, then what we have, then we have this will be after doing these operations, we have the matrix A equals to 1, 2, 3. We have to make this 0. So this will be 0 because we are doing this operation R2 minus R1, and this will be 2 minus 4. So it will be 2 minus 4. Sorry, R2 minus R1. So this will be 4 minus 2. This is 2, and then 2 minus 3, that is minus 1, and you have to do 2 minus 2, that is 0. Then 2 into R1, that is 6 minus 4, this is 2. Then 5 into 6, that is minus 1. So you have this matrix. After doing this operation, you have this matrix. Then what is our next step? We have to make this element, 0 with the help of this element. So now do this. 1, 2, 3, 0, 2, minus 1, and now if you subtract this 2 minus 2, that will be 0, and here also it will be 0. So now you can leave this row. So it is our opportunity, because we can leave this row and we have this matrix only as A equals to 1, 2, 3, 0, 2, minus 1, 0, 0, 0. Okay, so this matrix has the rank of 2 because you have 1 completely 0 rows and 2 non-zero rows. So this is the rank of the matrix. Okay, so this is the discussion, that is how you can actually apply the elementary row and column operation to determine the rank of the matrices. Also, you can determine the rank of matrices by different methods, but this type of operations is very helpful when you don't have any particular square matrix. Okay, so let us discuss different problems about the rank of the matrices. Okay, so we have one problem. So suppose you have this matrix so this is our question: find the rank of matrix 1 minus 1 minus 3 4 7 9 1 2 0. So now how to determine the rank of this type of matrix, because it is not a square matrix. This is 2 cross 4 order matrix, not a square matrix. So here we have this given matrix A. So now we have to transform this matrix. Okay, so at first, for this case, we have this matrix A. We have to transform this. Okay, so I am again writing this matrix 1 minus 3 4 7 9 1 2 0. This is our R1, this is R2. So we can make this element 0 with the help of this element. So make this. So now 1 minus 3 4 7. How to make this 0? You have to make this 0. So you have to multiply this by 9. So you have to modify this R2 as R2 minus 9 into R1. Okay, so 9 into R1 means 9 and 9 minus 9, that is equal to 0, and this is 1 minus 9 into R1, so this will be plus 1 minus, that is plus 27, this is 28, then this will be minus 34. Okay, and this will be minus 63. Okay, so now you have this matrix, and you can say these are two non-zero rows, and this type of forms of any matrix is known as echelon form. This is the pronunciation. This is known as echelon forms. So you have two non-zero rows. Okay, two non-zero rows, and you cannot find any minors whose determinant is 0 of order 2. Okay, so if you take this determinant, suppose 1 minus 3 is 0.28, this is not equals to 0. Okay, if you choose this minus 3 comma 4 28 comma minus 34, this determinant, this is not equals to 0 also. So no minors of order 2 has 0 determinants. So you can safely say that this matrix has the rank of 2. Or shortly, you can look at this figure here. You make this 0, but this is a non-zero rows. This is also a non-zero rows. So you have two non-zero rows. You have two non-zero rows. So safely you can say that it has the rank of 2. Okay, next do another problem. Suppose we have this matrix 1 1 1 2 2 2 3 3 3. So what will be the determinant? What will be the rank? So find the rank. Find the rank of this matrix. So how to do this? This is very easy one, because you can simply make these two rows 0 easily. So modify this. This is our R1, this is our R2, this is our R3. So at first modify this R2 as R2 minus 2 into R1, and modify this R3 as R3 minus 3 into R1. So this is also a echelon form. If you do this, this is the pronunciation, and there are many pronunciation also, but I am using this pronunciation. So you have this 1 1 1 0 0 0 and 0 0 0. So you have two completely 0 rows and only one non-zero rows. This is only one non-zero rows. So it has rank obviously of 1. So these are many fundamental problems you have as the rank of the matrix. Okay, let us take another example. So suppose we have the matrix A 1 2 1 minus 1 0 2 2 1 minus 3. Now you have to determine the rank of the matrix. So you can do this directly to identify that if this matrix has completely non-zero determinant. Okay, so if it has some non-zero determinant, that is determinant of this matrix A is not equals to 0, then obviously this is a 3 cross 3 matrix, so you can say its rank is 3. Okay, so at first do this determinant. So determinant of A is 1 2 1 minus 1 0 2 2 1 minus 3. So how to look at this determinant? So you can say 1 2 1. Now to simplify this determinant, you can do operations, that is you can make this 0. Okay, so just do this operation, R2 plus R1 and R3 minus 2 into R1. So you can make this element to 0. Similar process, 1 to 1, 0 to 3, and this will be 0 minus 3 minus 5. Now this is very easy to evaluate the determinant. So now you can take this minus 10 and this will be minus plus 9. So the determinant will be minus 10 plus 9, that is equals to minus 1, that is equals to not equals to 0. So determinant A not equals to 0, so the rank is 3. Why this is rank 3? Because we have already learned that if a matrix has non-zero determinant and if it is a square matrix, then the order of the matrix is itself the rank of the matrix. So here it is a square matrix of rank 3 of order 3 cross 3 and it has non-zero determinant, that is determinant of A not equals to 0. So the rank is itself the order of the matrix. So this is equals to row of A, that is the rank of the matrix A equals to 3. So in our next lecture we will start with the discussion of linear vector space eigenvalues and eigenvectors of matrix. So please like our channel, subscribe to our channel. Thank you very much.